Welcome to the DevDays conference and the Hall for Languages and Frameworks. I'm excited to listen to Florent's session right now because, I'm a developer myself and I've not been developing for many years now. But when I was developing, I used SQL Server and Graph API was just trickling in. And I'm interested to see what Neo4j does with Graph API and in the cloud. So, Florent, the stage is yours.
Thank you. Second time is a charm, hopefully. So yeah, I'm here to talk about Neo4j in general, and more particularly about how you can effortlessly import data to Neo4j in the cloud. So no operations or transparent operations rather for you. And when I wrote this abstract, I had the newly released back then Beatles song Now and Then. So that's why I tried to. It might remind you of the rhythm of a particular song like Lucy in the Sky with Diamonds. So that's what I tried to do, and maybe I failed, which is why I feel I have to explain the weird title. So all right, moving on. So my name is Florent. I work remotely from France at Neo4j, and I'm part of the connectors team. And our goals in the connectors team is quite simple, is to make data movement from Neo4j and or to Neo4j as easy as possible and meet the users where they are. There are many different cloud vendors, there are many different technical stacks, so we try to be there and make them successful with Neo4j basically. And so today, what I'm going to do is basically in 3 parts, or rather 2.5, because the middle part is going to be quite quick. First, it's about Neo4j. So what's Neo4j? What's a graph database? What does Neo4j do? So I'm going to give a quick introduction about that. Then I will just talk about Neo4j in the cloud, and it's so easy that it's basically one slide. And then finally, the no-code import in that case will be a reference to Google Cloud Platform and their Dataflow runtime, and in specifically a Neo4j template, which makes it even easier to basically run in Dataflow. All right, that being said, let's move on. So what are graph databases in Neo4j? So you might be familiar with the relational model. Here we are talking about graph database, so it's a bit different. So graphs are made of mainly 2 main concepts. One of them is called node or vertex. You can read in the scientific literature and in some other products. We talk about nodes. And nodes have 0 to many labels. So labels are just a loose way to group nodes that have some similarity between each other. And then the data itself is basically stored as key value pairs on the node. So that's called property. Hence the property graph model, right? Because there are properties and you have labels as well. And then you can link nodes together, and this link is called relationship or edge, as you might see. Relationships are necessarily made of one start node and one end node. It can be the same node, right? But relationship must always be defined with one start and one end. Then they have exactly one type, which characterizes a little more what they do, and one direction that you are free to ignore, right? If you have bidirectional modeling, for instance, I don't know, I'm on Facebook and I'm friend with Patrick, then that's usually bidirectional, right? If I'm friend with Patrick, Patrick is friend with me. I'm not talking about real life here, but you have to define a direction, but then you can ignore it at query time. So one type, one direction, and same for nodes, right? Relationships also have 0 to many properties stored as key value pairs, where that's the data that you can get. And so that's really important, right? That relationships have to have a start and end nodes that have some implications that I'm going to explain a bit later. And so if we try to draw a quick comparison between a model you might be a bit more familiar with, which is a relational model. So I'm taking one example here. I'm not saying, so we have persons and groups, so something quite common, right? So I'm not saying that's the only way to model it as a graph or the only way to model it with a relational database, but that's something that I hope is at least intuitive enough. So if you have a bunch of persons, they will live in their own table. Same thing for groups. So you will have persons and groups, and if you're seasoned enough with relational databases, you will that I have many persons in a group, and a group can be a person can be part of many groups. That sounds like a many-to-many relationship, and how do we solve that in the relational world? We use a join table, right? That's our table in the middle. So we have like 2 business concepts, and 3 tables. With graphs, again, that's just one example. I'm not saying that's the only way to do it, but you could at least intuitively say, okay, persons are nodes, groups as well, and the fact that a particular person belongs to a particular group would be modeled by a relationship. And so that's what you get here, basically, which hopefully looks a little bit more intuitive, right? I know we are mostly all seasoned with relational databases and we know how to handle this problem, but I've tried this with non-technical people and I had a hard time actually trying to explain join tables to them. Whereas on the representation on the right hand with the graph was a little more intuitive. So hopefully that gives you, some kind of intuition of what graph looks like and how a graph database operates. And then, if you cannot query, then you don't really have a database, right? And so we have what we call Cypher. And Cypher is a declarative query language. Why declarative? Because you say what you want to find, you don't say how. Pretty much like SQL, right? SQL is quite declarative. And in that case, you will define patterns. So in that case, what I'm trying to do, I'm trying to find actors who acted in a particular movie and return the actor's name. And if we look, basically, I'm trying to describe nodes with a label. So in that case, I have a particular node with a label actor. I have 2 of them that I've acted in. So, following the relationship type and direction, movie. And actually, what I'm showing is actually reverse. More or less, the execution is going to find first the most specific nodes, which is movie, and then backtracks from there and expand to actors. And so in that case, I have only one movie with the title, the matrix, in my database. And so I can expand and backtrack from that and find Carrie-Anne Moss and Keanu Reeves as a result and return that. So that's, again, a very quick intro, but that's more or less how you query data. Here I show the read query. You can, of course, create data as well. You have create, merge, clauses, etc., etc. And again, it's a quick intro. If you want to actually dive into a lot more details, we have what's called Graph Academy. So if you head for graphacademy.neo4j.com, you will find many, many, many great courses. They are completely free. They have self-paced, so you take as much time as you need, and you can learn all about Cypher. How about to query Neo4j, how you actually model business problems with a graph, how you can run optimized import. You will learn many different techniques, graph data science algorithms, and whatnot. There are many, many different great courses that my colleagues are working on. So feel free to dive in. I hope what I gave you was just a good enough taste for you to, to dive into this further. And by the way, since I'm talking about Cypher, I have to talk about GQL. That's quite a big deal. So you all know SQL. That is an ISO standard that started in 1987. And for the first time in almost 40 years, they announced a new ISO standard for a database query language. And this query language is called GQL. And GQL is basically graph query language. And that's a new ISO standard that has been announced last month. Don't get me wrong, it's been years in the making, but it's finally, GA. So if you learn Cypher, you will basically learn GQL. You will already be ready. So if you're afraid of vendor lock-in, for instance, don't be, because Cypher is and will continue to be the leading implementation of GQL. So yeah, graph databases are here to stay, and just having an ISO standard is just like a big proof of that. But let's talk about, here I'm here to talk about not so much about Neo4j only. I'm trying to talk about Neo4j first in the cloud and how to import data effortlessly to it. And as I told you, this part is going to be short. This part is one slide. We have what's called Aura. So Aura is our managed database offering. And we have a free tier. That's a great news, right? You can use it for free, no credit card needed. You just register, and then here you go. You can spin up a Neo4j database for free and try to play with it. We have other tiers when you evolve in your learning journey and you start implementing, business solutions based on that. And so that's the Aura DB, so the main database, and we have graph data science for all your data science needs as well. And if you're if you feel like you want to have a little more control about how you instantiate those instances and whatnot, we even have the Aura API, and the Aura CLI actually uses that to control instances and whatnot. And that's what I'm going to be using for my demo today. I'm going to have a pre-created AuraDB instance that I'm going to import data to. And you can do the same yourself afterwards. And finally, so that's what I'm here to talk about, the no-code import. What is it about? So we have what's called a Dataflow template for Neo4j, and I'm going to explain this a little more. So first, what's Dataflow? So Dataflow is a managed data processing platform on Google Cloud Platform. And what it does, it runs data pipelines, data transformation pipelines. You have sources, you have sinks, and transformation in between. That's what it's about. Technically, the pipelines are defined with a library or framework called Apache Beam, which is available in multiple languages like Java, Python, Golang. And that gives you an API to describe your data pipelines. And then you can target different runtime. And Dataflow is just one runtime among others to run those pipelines. And that sounds like a lot of things to learn, but that's why they also have what's called Dataflow templates. So you don't have to be an Apache Beam expert or even know Apache Beam at all for starters, for common scenarios. And it just turns out that we worked quite hard on offering a Neo4j template. So you will find them as part of the default templates. Now it's gone GA recently, so generally available. And what it does today, so I'm saying Dataflow template for Neo4j, but I'm just going to say Neo4j template. It's much shorter. What it supports today is you can query BigQuery. So BigQuery is a data warehouse system, an aggregation of different data sources exposed as a SQL database. That's BigQuery. So that's one possible source. You can use cloud storage. So cloud storage is like the S3 of Google Cloud Platform, when you can store data, you can store text files, binary files, and whatnot. And what you're going to do with that, you're going to declare various sources. So, different queries for BigQuery, different CSV files hosted on Google Cloud Storage. And then you will declare how to map them to your nodes and relationships of your graph. And doing that, you don't have to code in any particular language. It's just going to be a JSON specification, as we call. You don't need to know Cypher. And as I said earlier, you don't even need to know Apache Beam, right? That's all about, that's why the no-code, don't get me wrong, no-code can be a bit misleading. When you have big transformations, you will have like a big pile of JSON to write and transform. So no code, but still potentially lots of JSON. I'm going to keep it to reasonable levels for this talk, but yeah, no code, or rather, some JSON for sure. And so what does a Neo4j template do in a nutshell? So it will parse your sources, fetch the metadata to understand the schema if there is one, and then fetch the data by batches, gradually. It's going to read how you map that data to your Neo4j nodes and relationships, transform that into Cypher queries to run against Neo4j, and then run them gradually, right? And by doing so, we also try our best to do, to follow good practices when you work with Neo4j. So one of them is indexing, right? You want indices defined upfront. That's true for Neo4j. That's true for every database out there. We also want to have sensible defaults, so you don't have to think about it when you start, which is about, because you have potentially a lot of data to import, we don't want to run that into a single transaction, right? Because that transaction might run into memory issues or crash. So we want to cut that into different transactions. So we try to find the best default for the number of transactions related to the memory we consume. So that's something we're trying to do. And something, let me see how much time I left. Let me talk about it because I think it's important. Remember earlier I said relationships cannot be created without a start and end node, right? And so what happens? You could define a start and end node, and maybe another transaction concurrently deletes one of those, right? That could be happening, except it's not happening. And the reason is when you create a relationship or when you update it, because you could change the start or end node, we will lock onto those nodes, because for the lifetime of the transaction, we want to be sure that when we commit that transaction, that relationship refers to existing nodes. We want to do that. And what happens, and when you have concurrent queries running, potentially they are interfering with each other. And because relationship locks their start and end node, you might try to lock onto the same node by two different transactions, and then you will run into deadlocks. And what we're trying to do here, we're trying to be smart about how to partition the imports so that the nodes are not locked at the same time by different queries, and then you don't have to run into deadlocks. And even if you do, we use retries, etc., to make sure that eventually the import will run fine. So a lot of things we do under the hood. I'm talking about this even though the template tries to take care of it for you, because you might run Neo4j outside the Neo4j template as well, and that's something to keep in mind, right? So relationship deadlocks, because we want consistent relationships, we have to do these kind of things to prevent, to keep integrity rather. And so the template basically requires two things. The first thing is the specification I talked about, that specify your data sources, the mapping of this source data to your graph, so nodes and relationships. And also it needs a destination, right? Because we import to Neo4j, so we need to know where that Neo4j is. And you have two options basically to specify this Neo4j location. So when I say location, it's URI, username, password, or other ways of authentication. We support more than that, like a single sign-on and whatnot. So you can specify it as a JSON file in GCS, so Google Cloud Storage, or you can specify it as a secret. So the JSON payload will be encoded as a secret, and we will use Google Secret Manager to fetch it, which is a bit more secure, and that's what I would advise for production workloads. For the demo, I keep it simple. I just use a GCS URI, but again, for production, probably better, even though Google Cloud Storage by default is not sharing anything publicly, right? Your resources are secure. Secrets, using secrets is slightly more secure than Google Cloud Storage. And I'm going to start the demo right now, and I'm going to come back to it for a reason. So first, I'm using Aura, right? So I have this database here. Just we're going to make sure, no, I'm not cheating. So first, yes, I need to authenticate. And I'm not going to show my password to you, even though I'm going to destroy the database after the talk. But so I'm using an AuraDB instance. That's maybe the only Cypher query you will see. I'm just going to count the nodes because, relationships cannot exist without nodes. So if I have 0 nodes, then I have an empty database. So let's see. And I have 0 nodes. All right, so I'm not cheating. The database is empty. All right, all good. So I have a live database. Then what I need is to, so I'm in Dataflow. I'm in Google Cloud Dataflow. Maybe I can zoom in a little more even. And you can create a job by yourself, using the Dataflow API and using Apache Beam, etc. Or you can use a template. So let's do that. You need to give the job a name, so you can find it in the history list easily. So let's say hello DevDays or something. Then the region is important. So in my case, everything is located, especially the Google Cloud Storage bit, right? They're located in Europe, and also because it's closer to me, right? So I don't want to waste some time. So I'm going to pick Paris, which is likely the closest location to me. Then Neo4j, if you filter through the templates, you will see this Google Cloud to Neo4j, and that's the one you want to use in that case. And it will fetch the metadata about the template, read what are the parameters. So the first thing it asks is the specification, and I'm going to come back to the content, right? Right now, I'm just starting the job. I will explain a little more what it does. So bear with me for a second. So it needs this GS. So GS is basically for Google Cloud Storage. That's their pseudo scheme for it. So I'm going to pick the path to the spec. So you can actually click on browse, and it will find your workspace. So in that case, I'm just going to use this one. And then there is some slight annoying UI limitation, because I told you the Neo4j database can be located in two ways, either via a secret or via a plain GCS URI like the spec. I mean, it's mandatory, but none of them are individually required. And because of that, they're working on it. But currently, it shows up as optional parameter, but they are not optional. You need to specify this one, the first field, or the second one. So yeah, don't miss it, because otherwise we won't have any information about where the database is, so we cannot import anything to it, obviously. So in that case, because it's a demo, it's not production, I'm just going to use that particular file. And those are not public files, by the way, right? Because I'm implicitly authenticated with the same account, it knows how to fetch those using my permissions. And once that's done, well, we'll just start it and we'll come back to it. So there is a lot of technical settings. You can turn a lot of knobs to get super fine-grained executions. We don't need to do that today, so I'm not going to explain them one by one. Let's just run the job and wait a little bit. We'll come back to it, right? It will try to understand. It will boot up a VM, try to understand what your pipeline looks like, and then it will actually run it. All right. So let's come back to the presentation. And so let's dive into the specification a little more. So as I told you, there are two main concepts. There are a bit more than that, actually, but I'm keeping it simple for today. We have sources, which can be BigQuery or CSV files, and we have targets. And you also have a few other things. So sink, in that case, here it's a picture of Apache Beam, right? Or even though it's translated as an Apache Beam pipeline, the sink, as you can guess, is a Neo4j instance that you configured. That's implicit in our case, right? You import to a specific Neo4j instance, so there is no sink concept in the specification because that's implicit for the whole job. And so, yeah, two sources, what they do. So BigQuery, basically, a source is a query. It can be a join query, you can join several tables and whatnot. And you select the fields you want, and we will extract them and make them available for mapping. All sources have a name, and that name will be used by targets to refer to sources. Then text target, what we call text, so CSV. You have a CSV header, so that's important. The CSV files must not have any headers in their content. So the first line of the CSV must be the first row of data, not a header. You have the GCS URI, as I showed earlier. Then you can customize delimiter, separator, etc., etc. You have a lot of other options. Again, keeping it simple for today. The delimiter has a default value separator as well, so I'm not going to override those. Then we have targets. We have three kinds. I'm going to show you the first two today because, again, I don't want to show you any Cypher just to prove a point, which is you don't need to know Cypher, except I showed you one Cypher query already, right, to make sure the database is empty. But yeah, that was just one exception. I hope you will forgive me for it. So you have nodes or relationships. And what you can do, basically, you see what we call a target. So each target depends on a single source. So remember the name of the source? Well, that's what we're going to write here. The source attribute refers to the name of the data source you want to map data from. Each target has a name. And then depending on what you want to do, so let's focus on the first two. I mean, the third one is easy, right? Cypher query, you just write a Cypher query. You will get auto-injected parameters, which correspond to the current batch of data available. And then, you write whatever you want with it, basically. It's completely freeform. So it's much more flexible, but usually node and relationships are good enough for starters. So you can specify as many labels as you need for your nodes, as many keys. So keys is basically a property that act, you can think of like primary keys, for instance, right? Or this kind of thing. So that's more or less your primary key that you can define as well. And then you define your mappings, how this field from my source is mapped to a property in my node. So that's what the field mappings are about. There is a lot more. Again, keeping it simple for today. Hopefully you will be motivated enough to learn more. And we have a very great documentation we work recently on, so you can learn a lot more by following these. Then relationships, same story. You have a type, right? Relationships have a single type, they don't have labels. They have keys as well, potentially. And you also must specify what their start node and end node look like. That's a specificity of relationships. They connect to nodes. And of course, you can optionally define properties for that relationship as well, which is a mapping between source fields and relationship properties. So that's, in a nutshell, what targets are. And we'll look concretely into that right now. So let me show you what the spec I'm running looks like. Okay, I thought I had it, but yeah, it's right there. All right. So in that case, I'm using BigQuery. So I have prepared these tables, London stations and London tube lines. And as you might guess, is about the network of the underground stations in London. So we have, standard SQL queries that BigQuery support. Remember, BigQuery cosplays as a relational database, even though it aggregates from multiple data sources. So you have different attributes like station name, latitude, longitude, postcode, and whatnot. So that's my first source, which I call stations. And then I have the lines, right? So lines is basically a series, a path going through different stations with a start and an end. And so that's what I query here with this query. So those are my sources, which is great. So now let's move on targets. I have a first target, which will be a node, right? I mean, a node, like a node shape, rather. It's not a node. It might result in multiple nodes depending on the number of rows I map from. But, that's a node shape, let's call it. So I depend, this particular node shape will map data from the station source. So the first one right there, right? These stations here. So, I have station name, latitude, longitude. I give it a name station, just to be intelligible, understandable. Then mode append means I will create all the time, right? I don't care about duplicates. I assume the source is properly sanitized. Transform is not very important. It's just doing a group by under the hood with the source query. And then the mappings is where the fun happens. So you define one-to-many label. You can ignore this weird, you cannot ignore it at the moment, but yeah, don't get fixated on syntax. I'm gonna come back to that at the end, but the syntax is gonna change. It's gonna be a lot simpler. But unfortunately, for literal strings, for now, for labels, you have to quote them. So you have quotes in quotes, which is not great, but it's gonna change. So yeah, don't get too fixated on this. It's gonna improve soon. So here I have a single label, which is station. So I will have nodes with little station labels. Then I will have a key. So a key property, which is going to act as my primary key, if you prefer. So it's going to be the source. A source field is called ID, right? So I have this select ID here. So I have this ID field that I'm going to map to a property called station ID. So that's what this syntax means. Source field, this name for the source field is going to be mapped to this property name. And then I can group the other properties by type. So all of them are strings. So your station name is just going to be mapped at name, which is a bit more idiomatic in terms of casing on the Neo4j side. Same with zone and zone, postcode and postcode. And then I have the longitude and latitude, which I mapped similarly. So that's my first target. And then I have, so unfortunately, it's called edge here, even though at Neo4j we say relationship. So that's a past decision that we'll revisit as well, right? So as part of fixing a few syntax issues, we'll also fix that. So it's not going to be, this format is going to be maintained, right? We don't want to break compatibility, but there's going to be a new format with this relationship. So that being said, again, every target needs a source. In that case, we're mapping tube lines. So the second source here, we have tube line from station to station. So those are names of the start and end for each fragment of the line, so to say. So in that case, I'm going to use merge, which is upsert, right? So if it exists, do not create it again. If it does not, then create it. That's what it means. That way, I'm not going to create duplicate relationships. So again, and in that case, first, for every relationship, I need to find or create, right? I need to find or create start and end nodes. In that case, because the previous target has created the stations, I'm telling you need to find them. So find them in cipher means match. That's the select equivalent, if you will. So this means, and that's the default value when you're using merge anyway, but just to be explicit, this means find the nodes and then connect them. So we're not going to recreate stations if they already exist. Then the mappings is about how we map data from the source world to the graph world. And in that case, we have a type connected to, which will be from the start node, which is unfortunately called source. Again, new format soon, better words, better choice of words. So that's your start node, which must have the station label. And the from station value coming from the source query, remember, we have from station and to station, will be mapped to the name property. So that's how we're going to find our start node. We're going to find station with the name whose value corresponds to the from station field value. And same thing for the target, which is our end node for this relationship shape. So same label, except here we're mapping from the to station field to the name property. And we're basically going to match that and then connect them with the merge statement. So if that connection is already there, we're not going to recreate it. And that's it. So that's all what the spec does, and that's what I'm currently running. So let's have a look at our Dataflow job. And you can see it's succeeded already. So you can see many steps. It fetches metadata to understand the schema a little bit. Then is waiting for sources to be completely fetched and resolved. Then we start with the station nodes. And once we're done, we're basically taking care of edges or relationships, and we write them to the database, which is cool. So in theory now, I have a full underground network in my graph database. So let's have a look. And I promised I'm not going to reuse the query shortcut I did before. I'm going to use the explore. So this one, the query opens a tool called Neo4j browser, which allows you to run Cypher queries on top of your datasets. And explore is called Bloom, which is more of an exploration tool when you don't have necessarily to use Cypher. You can just use natural text, and it will try its best to translate it into Cypher for you based on your dataset. So let's try that. So again, I need to authenticate. So let me, again, not show my password, but use it. Maybe I should use one password for this. And let's connect. So I'm going to restore the same it's called a perspective, what you see here. And what's nice here is it's using the coordinate layout. So you have different layouts. By default, it's using the force-based layout. But here I'm using the coordinate layout where it maps. It tries to find, by default, and you can change it yourself, it tries to find how to map longitudinal or X and Y. In that case, we have longitude and latitude, so it just works out of the box. And you have more or less what looks like the physical layout of the underground, right? Because we're using the geographical coordinates. So here under your eyes, you have this network geographically laid out. But let's try to solve my problem. I'm traveling from Paris when I go to the London office of Neo4j. So I'm using the Eurostar train, which I believe stops at St. Pancras station in London. And I want to arrive to the closest station of the Neo4j London office, which is called, they pronounce it very weirdly. I think it's called, I would say Southwark, but that's not how they say it, Southard or something. I know, pronunciation. It's hypocritical coming from French. I know French is not easy to pronounce, but this particular name is very, very strange. All right, so I have a couple of minutes left, so let's try this. So what I'm going to do is trying to find the shortest path between, southward and St. Pancras. And hopefully it should zoom in the relevant section. And let's see. And actually I have so let's try to run this and see if it works. No, not found, because I think it's shortest path actually. Yeah, shortest looks a little bit weird. So let me try again. Else it's a demo effect. Shortest path, maybe better. No, not found. All right. So let me double check something. So perspective, saved cipher. Ah, yeah, of course, because my magic phrase seems, yeah, here is some cipher under the hood. So yeah, you uncovered my magic trick, but that's life. So shortest path between station 1 and station 2. So there is some cipher when you need some, something a bit more complex than just finding a particular node. So let me double check. I have a station whose name should contain my parameter here. And then I have another station where the name should contain it. Okay, yeah, so that should work. Let's try again. And if it doesn't work, I will try something simpler first, because I still have some time. So yeah, first let's try to find my station. So I have stations, it detects that. And I'm interested by the name, which should be South something, work. I always forget. Let's try. Is this correct? Where is it? Yes. Okay, so it's right there. Southwark or Southwark. I don't know how to say it, and British people will laugh at me anyway. Okay, so that exists, and is there? So let's try again a search. I'm looking for a station by name, and the name should be St. Pancras or something. let's say contains, or maybe even equal. I think maybe that works. Let's see. Okay, so it's found. Okay, so let's try again my trick, and if it doesn't work, then so be it. That's life. Sometime. So if I shortest path between south, I'm trying to be careful here. Work, yes. So it completes it for me because it knows the data set. And Saint Pancras, yes. So if it auto-completes it, hopefully it will find it this time. And if I run it, okay, here we go. So there is a small highlighting bug, but it tells me 6 not found, and it actually show me. So if I zoom out a tiny bit, I should have Southwark here, and I should have my Saint Pancras, I think above, where is it, King Cross? So I think we have King Cross here. Yeah, Saint Pancras, here you go, and Saint Pancras is here. Yeah, I'm not gonna unveil the whole. So we have Saint Pancras, which is connected to Farringdon. Let me try to solve it at both hands. So highlighting would have been great, but that's how it is. Then it's connected to something in this bag of nodes. But yeah, believe me when I tell you it found the shortest path, it probably did, right? Yeah, so here you go. Southwark, London Bridge, Bank, Liverpool Street, Farringdon, St. Pancras. So I ignore directions here because, they are more or less bidirectional in that case. Not always, but most of the time. So it found me the shortest path, so now I know what itinerary to follow to actually be able to go from the train station, international train station, to the office. And that was my demo. So yeah, unfortunately, I had to reveal my magic trick, which is called saved cipher query. So I used some cipher. I lied to you a little bit, and I'm sorry about that, but it was supposed to work on the first try, but yeah, that's life. But hopefully, yes, that gives you some idea of capabilities of Neo4j. And, I used very little cipher in the end, right? If you know the shortest path function, and if you don't, you can use Graph Academy to learn more about it. You can do very powerful things. And shortest path is just one example of the graphy things you can do with your data. All right, so import ran successfully. I was able to find my way from the London International Station to the station closest to the Neo4j office. So that wraps it up. So as I told you, don't get fixated too much on the JSON syntax I showed you if you're interested in using the Dataflow template for Neo4j. We are working hard. It's going to get released soon on an import spec project, which is going to be used by Dataflow and hopefully by many more of our connectors. And the syntax is going to be much more streamlined, much less ambiguous, and using the words we are used to when dealing with Neo4j, nodes, relationship, no edges, etc. And then probably, I'm saying probably because I don't want to commit to any deadlines or anything, we're going to work on more source types, right? We only support BigQuery and CSV at the moment. We are going to add more support, maybe for Parquet or these kind of sources, right? Or relational databases, even like with JDBC or these kind of solutions. We're also going to try to be even smarter about parallelization because, by default, we want to avoid the famous node lock I told you about with relationships. We try to run relationships single-threaded, but, we can be smarter than that. Sometimes there are ways to segregate the data so you can actually run relationship imports in parallel. We just took the easy strategy first, and we're going to work on smarter ways later. Then we're going to allow more flexible data conversion. Let's say you have a string field and you want to transform it to something else. We're going to work on making that happen. And also, we've been asked a couple of times about Neo4j exports. I talked about Neo4j import. What about Neo4j exports? Or maybe Neo4j as a source even. You can do Neo4j to Neo4j maybe as an import. So that's the kind of scenarios we're planning to work on. And with that being said, I took a little more time, I guess. I'm not sure there is enough time for questions. But I'm all ears if you have any. Please go to Graph Academy and Aura, to learn more about Neo4j and try it out in real life. And please try our Neo4j template. When you get the slide, you will get the link to the demo, and you can try it yourself with very detailed instructions. And that's it. So thanks, everyone, and over to the DevDays friendly staff.
Thank you so much, Flora. It was a pleasure to listen to you. In fact, I think I have learned a lot today, And guess what? I keep traveling to London, and we always live near Southwark.
Southwark, here you go. Okay.
Yeah. And I'm with you on that. It's not a very easy station to pronounce. And when I saw that you were looking for directions from Southwark to St. Pancras, I was like, oh, that's an interesting route.
Yeah.
So next time I'm in London and I'm traveling in any route, I know Florence graph API or graph database is behind this.
Yes, most likely indeed. Hopefully a bit more refined than what I showed, but yeah, it's just to give an idea.
Thank you so much, Flora. I'm sure people are gonna love trying out what you shared with us today. And with that, I think we're coming to the end. So I'll have to put the thank you video on and have fun in the conference.
Thank you.
Bye.